Isang magandang buhay para sa ating lahat. So now we are going to discuss for the method of sections. So a portion of the truss is isolated as a free body by passing an imaginary cutting plane through the entire truss, separating it into two parts. So pag hinati mo, yan. So if possible, the separation should be done without cutting more than 3 members of the truss. So dapat pag kinat mo siya, dapat hindi ka sosobra sa 3. Ayan, 3 members ng truss. Kasi pagka more than that, medyo mahirap na siyang kuhanin o solve. Okay, so we shall then have 2 isolated parts of the truss, each consisting of a non-concurrent system of forces in equilibrium under the action or the known loads that act of each part and the unknown forces that the cut members of one part exert on the other. So when the force is only the member of the forces in a few members are desired, the method of section works well. So check natin, ayan, katulad yan. So hinati natin dito. So we have here 3. Yan, 2 members. So yan, isa na yun. So, pwede na kunin ang load na yun. So medyo okay lang siya, di ba? Pero to determine the force in member BD, ayan, BT, ayan. Itong BD na to, ayan. So, they pass a section through the truss shown and create a free body diagram for the left side. So, dito, you can assume it's a tension and compression. Okay lang yan. Kung anong gusto mo para at least, assumption mo lagi. Kasi kadalasan ina-assume nila ay tension. Pero, yan, pag nag-negative naman yung kuha mo, edi gawin natin compression. Okay, di ba? So with only 3 cut, the section of the equation for the static equilibrium may be applied to determine the unknown members, forces, including the FBD. Yun, FBD, force along BD section. BD. Okay, yan, di ba? For example, we have here a structure. So we have here 1,000. So ano natin, may hinge doon ng roller. So i-cut natin. If we're looking to BC, so yan, diyan. So we have assumed tension, compression, depende sa'yo kung anong gusto mong assume. Okay, so in the methods of section, a truss is divided into 2 parts by taking an imaginary cut. Diba? Kunyari, kakat mo lang yan. Diba? So shown here as A does A through the truss. So since truss members are subjected to only tensile or compressive forces along their length, the internal forces of the cut members also will be either tensile or compressive. So, with the same magnitude as the forces at the joint, this result is based on the equilibrium principle and Newton's third law of motion, which is the action-reaction force. So, step in analysis for the analysis. Ayan, check natin. Di ba? Nakita mo, oh? Ayun yung mga reaction niya. Ayan. Okay. First is you have to decide how you need to cut the truss. This is based on where you need to determine the forces. Di ba? And then where the total of the unknowns does not exceed 3. General yun, di ba? Okay, so decide which side of the cut truss will be easier to work with. Siyempre, mas konti, mas maganda, di ba? So if required, so determine the necessary support of the reaction by drawing the FBD. Remember the FBD. You have to draw the FBD. The entire truss and applying the E of B. Yan. Kasi hindi pwedeng hindi. Kasi dito, pag in-assume mo itong tension to, dapat tension din to. Ayan o. Tension, compression yun. Compression din yun. Diba? Pares lang. Okay. So, draw the FBD of the selected part of the cut truss. You need to indicate the unknown forces and the cut members. Initially, you may assume all the members at tension. Diba? Sabi ko nga kanina. As done when using the method of joints upon solving, if its answer is positive, the member is in tension as per your assumption. Kumbaga, yun yung inassume mo. If the answer is negative, the member is compression. Please note that you can assume forces to be either tension or compression by inspection as was done in figure above. Lastly, we have the apply the scalar equation of equilibrium to the selected cut section of the truss to solve for the unknown members forces. Please note, in most cases, it is possible to write one equation to solve for one unknown directly. So look for it and take advantage of such a shortcut. Okay, so for example, we have here uh, looking for the members of BC, DE, and DE. Pag nakita mo, ito yon, tsaka ito yon, di ba? So, definitely, may kakat yan, siyempre, di ba? O, parang gano'n. So, ito is, alam natin, this is 5, and this is 2. Kalahati niyan, yan, ito. This is 2, ayan. So, square root of 29, using the Pythagorean theorem. Okay? So, yan, 2 yan, ha? Okay. So, ito, the whole, ito is 4. Okay? So, from the section to the left, summation of forces of y is equal to 0. B. So, 5 over square root of 29. So, positive kasi going upward yan, di ba? Minus 80 minus 60 is equal to 0. So, makukuha natin BE natin, which is 150.75 kilonewton. Tension yan, di ba? Ayan o, tension. Okay? So, magmo-moment tayo sa E, ayon, para to solve for the other nawawala. So, check natin ang BC. So, I assume that is clockwise. So, BC is clockwise. Kaya positive yan. So, moment arm niya is 5. Ito. Diba? Minus 80. Moment arm is 6. Kasi 2 ito. Diba? 2 yun. Pagin natin. So, 2. Okay? Minus 60 multiplied by 2. Diba? Yan. 2 yun. Equals 0. So, makukuha natin yung BC natin. So, solving for the BC, we have 120 kilonewton. So, nakuha na natin yan. So, compression yan. Next, moment tayo sa B. Pag nag-moment tayo sa B, DE is clockwise. Teka, wait. Palitan natin ng kulay. Yan, DE. It is clockwise. So, moment arm niya ay 5. So, minus 80. Moment arm niya is 4. Is equal to 0. So, FDE is equal to 64 kilonewton. And is a tension. Diba? Ayan, tension yan. Madali lang, di ba? Kasi, pag titingin kakat mo section, syempre, depende doon sa lugar, sa hinahanap na member. Di ba? Mas magadali nga. Kasi yan. Check mo lang mabuti kung saan ka magkakat. Okay, next problem. So, we have here, so we at yung BD, CD, and CE. So, definitely, dito tayo magkakat. Di ba? Ganun lang yan. Okay. So, we have here, roller, going upward. So, summation of moment along the F. So, we have here, RA is 444, that is 12, minus 360 multiplied by 4 is equal to RA is equal to 120. So, this is 120. Yan. Okay, next. So, check na natin yung the same one kanina. So, i-assume natin to. Ito, kaya naging 3 over 4, this is 3, this is 4, ayan. Kaya square root of 5. Okay. So, pwede na tayo mag-moment tayo sa C. Pag nag-moment tayo sa C, so FBD tsaka RA. So, FBD is multiplied by 3 minus 120 times 4 equals 0. Kasi, this is clockwise and this is counterclockwise. Ayan. So, 160 kilonewton. So, we have here the value of FBD. Ayan. Next is you have to solve for the, yeah, this is compression. Ayan. Ayan, alam naman natin papasok. Summation of forces ng Y. So, FCD, ayan, pababa. Minus, ayan, inclined kasi siya, 3 over 4, 5. So, plus 120. Ito yun. Kasi going upward. Is equal to 0. So, we have here, FCD is 200. So, nakuha na natin yung FCD. Next, moment tayo. Another one. So, moment tayo sa D. So, FCE multiplied by 3. Yung moment arm niya. Minus 120 multiplied by, ilan to? 8. Diba? Equal 0. So, FCE is 320. So, madali lang, di ba? So, first thing you have to do is to analyze kung saan mapupunta yung ating mga dapat at karapat-dapat. So, you have to check for the members kung ano yung kailangan natin. At pag kinat mo, check mo kung natatouch yung hinahanap na tanong. Diba? Or kailangan mong hanapin. So, i-check mo mabuti yon. And then you have to assume for the extent detention or compression. Huwag ka matakot. Kasi, pag negative na yung sagot mo, palitan mo lang yung direction. Madali siyang solvein actually. So, you have to look for the members. And then, be sure na dapat, kailangan, nakikita mo yung mga dapat hanapin. Okay? So, hanggang dito na lang tayo. Maraming salamat sa muling pag-discuss.